Hello, Computer Science 4373 TA or Professor. This is the reverse engineer then re-engineering of an ultrasound machine. It's kind of a dumb project, but we don't have an actual ultrasound machine to work on, so this was our workaround. The idea of the project was to teach us how to use an ultrasound machine and program one. So the idea was first to get a ultrasound image from the internet, then do some post processing on it to get rid of the GUI, so this stuff and this stuff goes away, and this is what's left. Then we define our outline of our ultrasound image, and then we fill in this and get rid of these lines here, and then we cast rays and output the final output as this. It's kind of dumb, but like I said, we don't have a ultrasound machine to work with, so we also found out that with our program, we can manipulate the number of rays that get output by the program. And funnily enough, when you add more rays, the image becomes more clear. If you have less rays, it does this. It's a little less clear. We could have done interpolation to fix this problem, but it was just easier to do this because all you had to do is put one number somewhere in the script and multiply it to give it more rays. Well, anyways, we are going to now show you how to run the program. Wow. So the first thing we're going to want to do is clone it. So let's go to our repo and clone it. I would highly recommend running this on a RAM disk if you have one set up and have at least 6 gigs of memory available if you're going to run the big data set. If you're only going to run 1 or 2 files, it's no big deal. But if you run the big data set that I am going to show you, I would highly recommend this. But aside from that, let's continue. Git clone. And then let's get into here. So the first thing we're going to do is going to set it up. Found that this init script doesn't work very well. This is kind of outdated. I should get rid of this. I probably will by the time you end up doing this. But in Linux, go ahead and do this. What this does is it goes through each each package in the requirements.txt file and installs them individually. I'm going to go ahead and run that. If you're on Windows, just go ahead and open up the requirements.txt. It's not too long, it's just 7 packages, and individually install these with pip. If all of these packages should be there, if it's not, it's fine, especially with skit images, ski images, and Skippy. All these 3 are kind of duplicates. Some run on Linux, some run on Windows. I didn't figure out what the problem was, but let's just continue. So once you have all of these installed, we're going to go ahead and set it up. If there's no output, we're good. Now the next thing is we need to put an ultrasound image in our assets folder. So we have not done that. So let's go ahead and grab the ultrasound images that are in our Google Drive. So I will also put this link in the description of the video, and it will also be in the doc that we submit. So now that we've downloaded the file, let's go ahead and move it to here. I'm going to make a directory called this, and we're going to extract everything. Once you have extracted the entire folder, we're going to want to move or copy, it doesn't matter which, everything into our assets folder in our Git repository, or into your local clone. So now the assets folder should be filled with a bunch of images. So the reason why we use BMP images is because it's lossless, but you can use any other image type you can't want, except for GIFs. Do not use GIFs. Well, you can use, yeah, you don't, just avoid GIFs. That's all. So now we have everything set up. Let's run one singular file. So the way we do that is /start py, or if you're in Windows, do this python start.py -l, and the file that we want to do, we're going to do this file. Go ahead and run it, and it takes a minute to run, but it will get the job done. Just give it some time. So we're going to go ahead and cd into the output, and we use 00001, right? So I'll go ahead and show you what that file looks like. If we feh assets 00001.bmp, this is our original ultrasound image. And then after the processing is done, these are the two images. This is the rays. What it does is it takes this image plus this image to make this image. Now you don't see much of a difference, but there is some difference. Like, I don't know how to zoom in, but you can see little lines here, and that's because we don't have interpolation set up, and we don't really have the time for that. Well, anyways, this is our final project right here. It takes this and turns it into this. It's, like I said, it's stupid, but it does teach us how to make an ultrasound image. And just to show you around the code a little bit, basically what it does is start.python sets things up, sends it to src main.py, which also does a little more setup, and then it sends it to image processing. What image processing does is ultrasound image processing. This is our big file that actually does all of the image processing, and then turns it into rays, which are then sent to intensity array to image.python, which is the actual ultrasound replication. As you can see, there's two loops. We have num rays, and we have for range length RR. I think that's the length of the ray itself, because the rays are of multiple lengths. In a normal ultrasound, all the rays should be of the same length. The problem is that we don't have an ultrasound A, and B, it's kind of hard to do same length rays with an ultrasound image already. So this is the best way we could do it. Otherwise, it would have been closer, but it's basically just two loops to make our image, like how the examples that we've been shown to do all the time. And if you're curious if you can run multiple files multi-threaded for fun, you can in Linux. I have not set it up with Windows PowerShell because I don't really want to. That's a lot of work. But if you're running Linux, if you run the start.sh and you list the number of threads you want to allocate to the program, in my case, I want to allocate 14 threads to the program and run it, it'll start processing everything in the assets folder for you, and it'll put it into the output. So just let it run, and when it's done, I'll cut back. The threads are done now. And just to show you everything in the output folder, so this is all the stuff that's in the output folder. You can see that there's filled, and then there's regular, or we shouldn't say regular, but non-filled. So filled are these images. The ones that don't say filled are the rays. So let's go ahead and I'll just show you. So if you open up everything, so this is the file name. So and then if we go to the next file, it's filled. So that's the difference between the two. So we're just going to open up all the filled images, so I can show you what it looks like. You can see that the GUI still presents itself down here. I wasn't able to figure out how to get rid of this. So small artifacts like that are inevitable. We also have, you can see how much liquid is in this guy's bladder or female's bladder. And I can show you dynamically that the ultrasound machine works, or our duplicate of an ultrasound machine, because we don't have an actual ultrasound machine. Here's a baby, and then here's another bladder image, and then I think there's a couple other right here, some different ones that we found to put in there. So these two. Well, anyways, this is our project, the reverse engineering, and then reverse engineering of an ultrasound machine. Thank you for watching. Goodbye.